So, Jai Hind everyone. My name is Ritesh. I'm from AKGEC College, Ghaziabad, and today I'm going to take a lecture on the problems on nodal analysis. So, this is a topic from the subject Fundamental of Electrical Engineering. The subject code is BEE201. So, we have seen that how the nodal analysis is this technique is being solved or done to solve the circuit actually. Now today this lecture is basically to solve some problems based on nodal analysis. So let us take a few problems based on nodal and then try to solve them. Okay. So this is one of the problem which you have to find the current in the 1 ohm resistor of the given circuit using the nodal analysis techniques. So we all know that the nodal analysis techniques is based on the Kirchhoff's current law. So we have to apply the KCL at a particular junction. So first of all, in a particular circuit, we have to know how many nodes are there. Okay, we have to understand how many nodes are there. So by looking at these circuits, the node means a junction where the more than 3 branches are meet. Okay, means where the current is dividing. For example, in this circuit, we have a node number 1. Suppose this is junction. We can say that it is a node number 1. This is 1. This is node number 2 and node number 3. So these are the 3 nodes where the current is dividing. Okay. And one node you can say it's a reference node. We call it a reference node, or we also call it a zero potential node. Zero potential node or reference node. So the potential of this node is grounded. That means the potential of this node is 0 actually. Now our aim is to find the current in 1 ohm resistor. This is 1 ohm resistance. We have to find the current in this using the nodal analysis method. So for in this techniques, we have to assume the current in different branches. So in this circuit, suppose that the current in a different branches I1, I2, I3. These are the 3 current in 3 different branches: I1, I2, I3, I4, I5, I6. So these are the 1, 2, 3, 4, 5, 6 branches where the current is not known to us, and we have the 2 current sources with a given direction of current. Okay, so we have to apply the KCL at these 3 different nodes, 1, 2 and 3. So suppose that at node number 1, okay, so let us take first at node number 1. At this node, we can say that if we apply the KCL, that is the algebraic sum of the current at this node, that is node number 1, is 0. That means I1 at node 1. So at node 1, algebraic sum of the current, that is I1 plus I2 plus I3 equal to, now this current I1 plus I2 plus I3 current will be equal to that current which is coming to this node. That is, you can see the outgoing current is equal to incoming current. So this is equal to your 10 ampere. 10 ampere. Now this is our first node equation. Okay, we can call it as a node equations. Now next we need to replace this current by the respected voltage actually. So suppose this I1 current. So this is the I1 current is this current which is flowing in this branch. So the voltage as far as this branch is concerned is V1, this is V1, this is V2, and this is V3. This is we have to assume. We assume that the voltage V1, V2, V3 are the voltage of node 1, node 2 and node 3. Now here this I1 is given by V1 divided by the resistance, that is 2 ohm, plus I2 is the voltage, is a current in this branch, that is the potential difference between these two nodes 1 and 2 divided by the resistance, that is 3 ohm, that is V1 minus V2 upon 3, plus now I3 is given by this current which is between the node 1 and node 2. So the potential of node 1 and node 3 is V1 and V3. So V1 minus V3 upon the resistance, that is 5 ohm, and which is equal to 10. Now this is our first equation. Now we will simplify this equation, that is V1 1 by 2 plus 1 by 3 plus 1 by 5 minus V2 by 3 minus V3 by 5 equal to 10. V3 by 10 equal to 10. Now on simplification, we can write this equation as 31 V1 minus 10 V2 minus 6 V3 equal to 300. This is the calculation. So when we solve this, we will get this equation, and this is the first equation. This is the first equation. Since we have three variables V1, V2, V3, so we have to form the three equations. So this is the one of the equation at node 1. At node 1. So at node 1, this is the first equation. Now similarly at node 2. At node 2, we can see this, कि I2 will be equal to I4 plus I5. So at node 2, that is I2 is equal to I4 plus I5. I4 plus I5. Now again this I2 that we have already calculated, that is V1 minus V2 upon 3. So V1 minus V2 upon 3 is equal to I4, that is V2 upon 5, because this node having zero potential. So V2 upon 5 plus I5. I5 is a current in this branch, that is 1 ohm, that is V2 minus V3 upon 1. V2 minus V3 upon 1, that is the, or you can write it like this. Now on solving this equation, that is V1 upon 3 minus V2 1 by 3 plus 1 by 5 plus V1, V1, V2, V3 is equal to 0. Sorry, V3 is also here. Just V1, V2 and V3 is also there. Minus V3 equal to 0. So this is the second equation, and you can write this equation as 5V1 so this is plus 1. So 5V1. On solving, you can write this 5V1 minus 23V2, and the third 15V3 equal to 0. And this is the second equation. Now the third equation is based on this node, that is V3 at node 3. So I'm just writing here at third node. So at third node we can write the equation this I5, because the incoming current I5 and I3 plus I5, I3 plus I5, I3 plus I5 equal to I3 plus I5 equal to I6 plus 2. And since we know that I3 is equal to V1 minus V3, V1 minus V3 upon 5 plus I5 is equal to I5 is this current, that is V2 minus V3 upon 1 is equal to I6, which is this current, V3 upon 4 and plus 2. And by simplifying V1 minus V3 upon 5, V3 by 4 plus 2, and simply by solving this equation we can write that 4V1 plus 20V2 minus 29V3 is equal to 40. This is the third equation. So equation number 1, 2 and 3, by solving these three equations, three variables, so the answer will be V1 will be equal to 12.05 volt, V2 will be equal to your 5.1, V3 is equal to 3.8 volt. You can solve it by using calculator, by using linear equations, by using Cramer rules, but by solving the calculator is quite easy for you. Okay, just put the values and you can get the answer. You will get the answer of V1, V2 and V3. Now our object is to calculate the current in 1 ohm resistance, that is in this. This 1 ohm resistance means the current in 1 ohm resistance. So you can write here the current is in 1 ohm resistor will be equal to, now this is the resistor having potential V2 and V3. So V2 minus V3 divided by 1, that is 5.1 minus 3.8 upon 1, and it is equal to something around 1.3 volt. Sorry, ampere, not volt. This is the current. So 1.3 ampere current. So similarly, you can find current in any branch because you have all the three node voltages. So it's quite easy for us to calculate the current in any branch because all the voltage or the node voltage is known to us. Okay. So this is how we can solve. The answer is this. You can write the answer from this. So our answer is correct, students. Now, similarly, let us take another problem. Let us take another problem based on the nodal analysis, because once we understand the concept, now we have to apply by solving the few problems based on the nodal. So in this circuit, we have the two nodes. We can say 1 and 2, and this one is your ground node or zero potential node or reference node. So you can assume the current in different like I1, I2. So I1, I2 current you can assume. And now this is the V1 and V2 are the two voltages. Okay. And now from here we can, by just looking at the circuit, so this V2 and this node, there is a direct voltage source is connected. That means V2 is equal to 25 voltage, which V2 is positive. Because this is positive, this is negative. So it is given to us. This information is given to us from the circuit. Now I can write the nodal equation at node 1. So at node 1, at node 1, the equation is, you can say that I1 plus I2 is equal to 10 milliampere. So I1 plus I2 equal to 10 milliampere. I1 plus I2, these two are the two outgoing current, this is incoming current. So you can write I1 plus I2 equal to 10 milliampere, and I1 is equal to V1 upon 4 kiloampere. So V1 upon 4 kiloampere, and I2 is equal to V1 minus V2 upon 1 kiloampere. That is equal to 10 milliampere. This is what is given to us. Now just take the common and then substitute over there. So V1 upon 4 plus V1 minus V2 equal to 10. So you can solve it by taking the LCM all that. So this is 5V1 minus 4V2 equal to 40, equation number 1. Equation number 1 at node 1. Now V2 is given to us 25 voltage, so we can substitute over here. So from 5V1 minus 4 into 25 equal to 40. That is equal to 140. V1 will be equal to 140 divided by 5. And 1 divided by 5, it comes out to be 28. So 28 is the V1, and V2 we already calculated. This is 25. So find the voltage across 1 kilo ohm. So V1 and V2 is known to us. So we can calculate the voltage across 1 kilo ohm resistance. That is the voltage across across 1 kilo ohm resistor is equal to V1 minus V2, because this is the V1 is this is V2, and we have already calculated V1 is 28, V2 is 25. The difference is 3 volt. Hence, the difference between the voltage across 1 kilo ohm is nothing but it is 3 volt, where V1 is having at high polarity, that is at high voltage of 28, and V2 at 25. So the current will flow from node 1 to node 2. Okay, so we can calculate the according to the current in that branch also. So this one is the problem. Next problem is the find the node voltage Vx and Vy using nodal analysis for the circuit. Suppose that again in this problem we have to assume we have to be given the two nodes Vx and Vy, and you can say that we have the current in this branch is, suppose it is I1, I2, I3, I4. We have assumed that these are we have two nodes X and Y, and the voltage at this node is Vx and Vy, and the current, we have assumed that the current in the different branches in this direction. So this direction we assumed actually. Okay, it is just an assumptions. So next is to write the node equation. So at node X, at node X, X node, at this node, so I1 and I2. These are the outgoing current and this is the incoming current. So I1 plus I2, I1 plus I2 plus 2 equal to 10. This is or I1 plus I2 equal to 8. This is one equation. Okay, this is one equation. Now, replace this current I1 and I2 by their respective voltage. So, voltage I1 is Vx. This is a zero potential node. So, this the potential of this node will be 0. So, Vx upon 6. Vx upon 6 plus I2. I2 is this current, so Vx minus Vy divided by 4 ohm. Vx minus Vyy 4 ohm. This is the 4 ohm. 4 ohm is the resistance of this, is equal to 8. So you can solve these values by simple Vx 1 by 6 plus 1 by 4 minus Vy upon 4 equal to 8. And by solving this equation, you can write that at node X, this 5Vx minus 3Vy equal to 96. Equation number 1 at this node X. At this node X. Okay, first equation. At node Y, so at node Y, you can say that the current I3 and Iy is the outgoing current, and this I2 and 2 ampere is the incoming current. So I3 plus I4 at node Y. So I3 plus I4 equal to I3 plus I4 is equal to out2 plus 2. And here I3 is equal to Vy upon 10. Vy upon 10 plus I4 is this current, that is Vy upon 5. Because it's I3 and I4 both are associated with this node Vy. So the potential of this node is Vy is equal to I2. I2 we have taken Vx minus Vy minus Vy upon 4 plus 2. Okay, so you can solve this equation, and this equation will comes out to be, by after solving, is 5V1 minus 11Vy equal to minus 40. And this is our equation number 2. So question number 1 and 2, two equations, two variable. So Vx will be equal to, which comes out to be 29.4, and Vy equal to, this comes out to be 17 volt. So this is the answer of this question. So Vx and Vy is known to us. So once Vx and Vy is known to us, we can calculate the current in any branch, since we have the node voltages in this branch. So this is the one of the problem based on node analysis. Now one of the problems is basically based on the, this is the problem which is based on the super node. In this node we have the node, suppose this is V1 and V2. So these two nodes having only the voltage source. This types of problem is called the super node, because there is no resistance. So it is quite difficult for us to find the current in this branch. So such problems can be solved by simply eliminating these nodes or the current in this branch. So we can assume the current in this branch. Suppose I3 is this. This is suppose I1, I2, I3, I4 and I5. So we can eliminate this current by taking the KCL at these two current, and then one of the equation is V1 minus V2 is equal to 36, which is given to us. Since this has high potential, this has low potential. So you can solve this question and you can do it. So this is all about in this lecture. So I hope this lecture will be benefit for you and you can solve more problems based on Nodal. So thank you so much. Jai Hind.